Hi everyone, and welcome to Mod 5 in Unit 2. We're talking about the scientific method today. Here are the key terms in this module. Pause if you need to. So I'm going to quickly go over some of these terms, such as theory and hypothesis, but I know that you most likely have learned about them in a science class before. So a theory is an explanation of a behavior or event that offers ideas to organize things that we have observed. So you can theorize that better memory springs from more sleep. And then we might look for that behavior in our actions. Like, oh, I did better on that quiz. I remembered more vocab, and that day I had slept more, right? And we can make a theory about that, an explanation, but we need to test that theory in order to really believe it and trust it. So a hypothesis is a testable prediction. And I know you're probably familiar with the if-then statement that makes a hypothesis, where we put those ideas to the test. So you can say, I have a theory that sleep improves memory. It's quite a good theory. We'll talk about sleep later on. And then your hypothesis could be, when people are sleep deprived, they will remember less information from the day before. Now that is a prediction that you can now test and find out if it's true. So when we are creating experiments and we are looking at different variables in correlational studies, we need to define what these variables are. So an operational definition is a statement of procedures the researcher is going to use in order to measure a specific variable. If you are going to study happiness, well, what is your measurement of happiness? Because if it is a good experiment, it can be replicated. I can do this experiment again, and I can see if your results are correct. Because if one experiment is done and I can't ever replicate those results, in fact, I'm just finding the opposite of what you said to be true, then that shows that your results might not be correct. So it's very important to very specifically define all the variables in an experiment so that it can be replicated. If we say that overexertion leads to exhaustion, we need to define, in our experiment, overexertion was having to work more than 12 hours. Okay, so if you want to replicate our study, it can't be an 8-hour workday. It has to be a more than 12-hour workday. And then, well, at what point do you say the person is feeling exhaustion? We're defining that as extreme tiredness and incapacity to work more. And this study would have to go into specifically, we gave people this scale of measurement and kind of really clarify how they measured exhaustion in order for it to be correctly operationally defined and so that it can be replicated. So another example, students are more likely to smile for their senior pictures if they have a friendly photographer. We'll be talking about independent and dependent variables, but if you want to kind of look at that and pause it to figure out that in that experiment, you can. But here's my question to you. How many of the students on the following slide are smiling? How many of these would you count as smiles? And by the way, these are celebrities. So you can pause that if you want. So in order for this to be a good study, you need to define these independent variables. What does the photographer's friendliness mean? Tell me specifically, how did you measure friendliness? And how did you measure smiling? So that we know what we're all talking about in this experiment or in this study. And again, that replication part is important. If we want to be critical consumers of research, we need to always ask how the research variables were operationalized. Well, what getting more sleep makes people happy. Well, what is happiness? How was happiness studied? How did they test it? Asking those questions, being curious and skeptical to help us understand. When someone says, we're the best rated school, what do you mean? Who's rating you? And how many people? And were they already attending these schools? Lots of questions you could ask about someone stating that fact or stating that as fact. So replication itself is its own vocab word. It means just to repeat or recreate a study. And we must be able to do this. Ideally, can't always be done, but ideally, if we can do this, we can really help show that something is really significant, that, hey, sleep really does improve your mood or your memory, whatever it is we're studying. So when I'm throwing around these two words, different types of studies, there are correlational studies and experimental studies. A correlation is looking for relationships between two things already present. For example, you might be looking at ice cream sales and shark attacks, right? Correlation doesn't always mean causation. It doesn't mean that one causes the other, but there is a correlation between the increase of ice cream sales when they peak around August, apparently, and shark attacks, right? But does that mean that eating ice cream or buying ice cream causes shark attacks? No, right? So correlations, looking at two variables, it doesn't mean that they cause each other. Now, this is a silly example, but we could take, for example, women who are pregnant and smoking and the effects of that, right? We can't create an experiment where we put pregnant people in an experiment and we say, go smoke, right? But we can look at people who are making that choice and we can look for correlations. Are there any connections between premature birth and smoking during pregnancy? Or, in the right case, if it is ethical, we can conduct an experiment, which is a procedure that we carry out under controlled conditions in order to discover some sort of cause and effect. So only an experiment, this is important, I would write it down, only an experiment can tell us cause and effect. Correlation can find relationships between two variables, but not cause and effect. Super important. Pause to write down. There are 3 different types of correlational studies you need to know. A case study is just studying one person, usually in great depth. We're going to talk about someone, Phineas Gage, later on. That would be a correlation because he had a railroad metal rod shoot through his head and he lived to tell the day for many years after. That would not be something you would do as an experiment, right? That would be totally unethical, but it happened, and so they studied him to see how his brain was affected. You can also do a naturalistic observation, which is watching and recording behavior in its naturally occurring environment. So watching behaviors in our dining hall, or Jane Goodall, although sometimes she did kind of interact with them, right? But if you're just truly observing and not interfering in it, then it is a naturalistic observation. And then you can also do surveys, which is a very easy, efficient way to collect data. But you have to be careful with surveys because people can ask questions that are framed to get certain answers. So this is another vocab. It's known as framing. It's also sometimes called wording effects. I want to give you both in case either come up on the AP exam. So this is a subtle change in the order or the way the question is worded on a survey that changes the results. It changes the answers. For example, treatment A, 200 people will be saved by this treatment, right? Put in reverse, 400 people will die, right? One sounds way better, but both are the same. It's the same treatment. It's just how we are wording it. Would you take treatment A? 200 people will be saved, but you're like, well, how many are there? Or treatment B, a 1/3 probability of saving all 600 lives and 2/3 probability of saving no one. Or a 1/3 probability that no one will die and 2/3 probability that 600 people will die. So it's the same treatment, it's just wording it differently can make people have different feelings and different responses about it. Okay, so in a correlational study or an experiment, there is something called random sampling. Random sampling is a group that fairly represents the population intended. If we are trying to study college students, then the pool of people should be college students, but it should be random. If I am teaching Psych 101 at a local university and I'm just studying the people in my class, that is not a random sample. So a random sample fairly represents the entire population of people. So that would be more collecting from a variety of universities, a variety of levels of college, different majors, etc. So see this population, right? And it's got not everyone. You can't ask every single person in college your survey. That's not realistic. But you want to get a representative sample so that you can make a generalization with your results. You can say people in college get 7 hours of sleep on average. You want to be able to say that? Well, you need a representative sample that's accurate to your population. If you're only testing psychology students, that might be different because they learn about sleep and maybe they prioritize it more. If you don't do that, you have what's called sampling bias, which is a flawed sampling process that gives an unrepresentative sample. Okay, so these two words are often confused in an AP exam, so I want to make sure we're clear on them. So I just explained what a random sample is, to select participants for a study from the population without a bias. They are representative of the population. It allows you to generalize those results. Generalize is an important word there. This can be done in a correlation or an experiment. That is very important. I would write that down also. Random assignment is only used in an experiment. So I have my population, my whole population, all college students. Now I have my representative sample. Okay, I did a random sample to collect them. And now I'm going to actually conduct an experiment. I'm going to do a sleep experiment. So I need a control group and a treatment group. Well, I'm not going to say, oh, all of the people from New England colleges, you're going to be the control group. All the people from California, you're going to be in the other group, the treatment group. That would not be random assignment to which group you're getting into. So random assignment is only for experiments, and it's only about, are you going to be in the control group or are you going to be in the experimental treatment group? Okay, that's what randomly assigned is. And it's to prevent any sort of confounding variable. Like maybe people in the Northeast are not as good at sleeping versus people from California. So again, here's my sample. I either am going to a treatment group, I'm going to be my random sample, but here's my random assignment, either to a treatment group or a control group. So takeaways. Theories make connections between observations, but hypotheses predict and test them. All variables must be operationally defined because replication is important to test and retest our hypotheses. Only experiments can manipulate a variable, and therefore only experiments are using random assignment. All of them use random sampling. Correlation does not imply causation, shark attacks and ice cream sales. And wording effects in surveys can change the results of the survey. And all studies need a representative sample of the population. That sums up Mod 5, and I